Hello everyone, I am Muskan Nagar and today we are going to solve first internal paper of data science. So let's begin. This is the case study on based of which all the sections of this question paper are based. First section is statistical characterization of complaint data. First question. Give three commonly used statistical measures to characterize dispersion in complaint derived scores. Discuss how these measures can be computed efficiently over large complaint repositories. Three commonly used measures of dispersion: range, maximum, minimum, simple, sensitive to outliers; interquartile range, IQR, Q3, Q1, robust to outliers, describes spread of middle 50%. Standard deviation, SD or variance. Formula for standard deviation is square root of 1 upon n minus 1 into summation of xi minus x bar whole square. Um, Measures spread around mean, useful when data are approximately symmetric or normal. Efficient computation over large complaint repositories. Streaming one pass algorithm, Welford's algorithm of mean and variance, numeric stable single pass. Approximate sketches. T digest or Q digest of quantile. Fast, mergeable across partitions to compute median Q1, Q3 and IQR. Partitioned aggregation. Compute partial statistics on partitions, shreds, then merge mean count sum of squares to get global mean or variance. Reservoir sampling. For random sampling when dataset too large to store, then compute exact measures of sample with known sampling error. Histogram or bind counts. For coarse approximation of distribution and median can be refined in interpolation. The second question is sorted evidence strength for score 1 to 100 extracted from complaint text. This is the score of the students. We have to find all of these from this data. First, we will find mean and median. Mean is sum of values upon 27, that is the number of elements in this. And after solving, we get 29.76 as mean. Median is middle of 27 values, that is 14th value. Here it is 25. B part, we have to find mode and modality. First, we will find frequency of all the elements, and the highest frequency of is of 25 and 35, that is 4. Here we found two modes, so it is bimodal distribution. C part is to find mid-range. To find mid-range, we have to find average of min and max element of the data. That is 13 and 70. 13 plus 70 divided by 2, that is 41.5. D part is to estimate Q1 and Q3 using the usual 25%, 75% sample quantiles. Q1 will be 20.5 and Q3 will be 35.0. E part is to 5. E part is asking for 5 number summary. It will be min is 13, Q1 is 20.5, median is 25, Q3 is 35.0 and max is 70. These are 5 number summary. F part is asking for the box plot, and this will be the plot for this data. Last part is QQ plot versus quantile plot difference it is asking for. Quantile plot plots quantile level probability P on X versus the sample quantile value XP and on Y. It shows how the data quantile change with probability. Useful to visualize the distribution shape, skewness, plateaus. QQ plot, quantile plot. Plot quantiles of your sample against quantile of a theoretical distribution, example normal, or another sample. If sample quantile align roughly on 75% degree line, the sample follows the theoretical distribution. Use use QQ of test whether evidence scores follow a particular target distribution assumed by DSS. Example normal. Use quantile plot to visualize the distribution form itself, skew or multimobility, without directly comparing to a reference distribution.